Hello everyone, welcome to second PUC Tungal online classes. In the previous chapter, we were learning about the magnetism. The chapter was moving charges and magnetism. In the chapter, we were learning that the magnetism and electricity are interrelated to each other. I mean, the source of the magnetic field is nothing but moving charge. Wherever charge is moving, magnetic field was produced. Now, in this chapter, we are going to learn in detail concern to magnetism and the concept of magnetic field lines. Actually, the concept of magnetism goes to our ancestors. In the place of Magnesia, before Christ 600 BC, their peoples found that the certain kind of material that was available in the nature, that material has able to attract the small pieces of iron, nickel, cobalt, etc. That material those called as magnet. I mean, the concept of magnetism is was known in very previous long time. Now let us see in detail. In this chapter we are going to learn mainly about the magnet, the property of magnet, and how the magnetic field lines are arises. That we will see in detail. The concept is magnet. See here. Actually, magnet is available in the nature in the form of iron oxide. The natural magnet is called as magnetite. Its chemical formula is Fe3O4. This material available in the earth crust of the very small amount, and this material has ability to attract the small pieces of iron, nickel, cobalt, and aligns in a north-south direction when it is freely suspended. See here, what I am calling? The natural magnet that we are calling magnetite. Magnetite is a natural magnet. It is a natural magnet. This magnetite is available in the blackish brown color, so that this natural magnetite is also called as a black stone, or it is also called as a lodestone, and it is also called as a leading stone. Its chemical formula is Fe3O4, natural magnet. But in practice, this natural magnet has a weak magnetic field. I mean, it has not enough strong magnetic field to utilize for further commercial purposes. So that when natural magnet, when it is well polished, or when current is passing in the magnetic materials like iron, nickel, cobalt, we can make the so many shape of the magnets. Those shape or different shape of the magnets we are calling as artificial magnets. Artificial magnets mean the man-made magnets, so those are called artificial magnets. See here, the man-made magnets, man-made magnets, man-made magnets are called as artificial magnets. Artificial magnets. See here, we can give different shape by passing a current in the iron core or nickel or cobalt, or when natural magnet well polished and given to definite shape, those we are calling natural magnets. Actually, there are three types of natural magnets are available. One we are calling bar magnet, second one we are calling magnetic needle, and the third one we are calling U-shaped magnet or horseshoe magnet. See here, the artificial magnets are, first one is bar magnet, second one is magnetic needle, and third one is U-shaped magnet. U-shaped magnet. U-shaped magnet. Now in this chapter mainly we will see what is mean by magnet and what is mean by bar magnet and what are their properties. In detail we will see. Now initially let us start from the concept of magnet. See here, look at me, let us see the magnet, then later we will see what is bar magnet and what are the properties of the bar magnet, that in detail we will see. Initially magnet mean the substance which attracts the small pieces of iron, nickel, cobalt, etc. and has the two poles, one we are calling north pole and south pole. That material we are calling magnet. Simply, the material which attract the small pieces of iron, nickel, cobalt, that material is called as magnet. So here, any magnet that consists of two poles, one we are calling north pole and second one we are calling south pole. Each magnet has two poles. We will come to the point which one we are calling north pole and which one we are calling south pole. See here, simply magnet means the substance which attracts small pieces of iron, nickel, cobalt, etc. That material we are calling magnet. And the property of the magnet which attract the small pieces of iron, nickel, cobalt, etc. That property we are calling magnetism. Magnetism means the property of matter or the property of material which attract the small pieces of iron, nickel, cobalt. That property we are calling magnetism. So here our concept is we have to learn in detail about the bar magnet. What is the bar magnet and what are the property of the bar magnet, that in detail we will see. Actually, bar magnet, it is an artificial magnet. Bar magnet. See here. Bar magnet means the rectangular shape magnet which attracts the small pieces of iron, nickel, cobalt, etc. That material we are calling bar magnet. How it is looks like? See here. The rectangular shape object which attract the small pieces of iron, nickel, cobalt, that material we are calling bar magnet. I already said that each magnet consists of two poles. One we are calling north pole and second one we are calling south pole. So here, the line joining from north pole to south pole is called as magnetic length. What is the magnetic length? The line joining from north pole to south pole, this we are calling magnetic length. Always the magnetic length can be represented by the distance 2L, because we have to take from the center. From the center if we take O point, from north pole to center we are calling L, and from south pole to center we are calling L. The total length of the magnetic length can be taken as 2L. Then let us see in detail what are the properties of the bar magnet. In detail we will see. Let us see the one by one property of the bar magnet. See here, already that the bar magnet is a rectangular cross section, rectangular shape of the magnet or material which attract the small pieces of iron, nickel, cobalt. That we are calling bar magnet. The first property of the bar magnet, let us see in detail concern to properties of the bar magnet. See here, in detail we will see now. Properties of bar magnet. Concept is properties of bar magnet. See here. The first property is nothing but property of attraction. First property is property of attraction. property of attraction. See here how the bar magnet looks like. A rectangular cross shape of the magnet which attract the small pieces of iron, nickel, cobalt, that we are calling bar magnet. This is the north pole and we are calling south pole, and this is nothing but the magnetic length. Are you following? Property of attraction means near the bar magnet, if you bring the small pieces of iron, nickel, cobalt, those sides or those poles attract the materials. This we are calling property of attraction. Property of attraction means the poles of the magnet which attract the small pieces of iron, nickel, cobalt, that we are calling property of attraction. So here the property of attraction can be represented by one physical quantity that we are calling pole strength. Let us define the pole strength. Pole strength. It is represented by symbol small m. See here. Pole strength means the ability of the magnet which attract the small pieces of iron, nickel, cobalt, that property we are calling pole strength. Simply how to say? The ability of the poles to attract the small pieces of iron, nickel, cobalt, that ability we are calling pole strength. And the pole strength, it is situated nearly at the end of the magnet. But not exactly at the end of the magnet. ನಾನು ಹೇಳಿಕತ್ತೀನಿ ಈ ಪೋಲ್ ಸ್ಟ್ರೆಂತ್ ಅನ್ನೋದು ಮ್ಯಾಗ್ನೆಟ್ ಅದ ನಿಯರ್ ಇರ್ತದ, ದಂಡಿಗೆ ಇರ್ತದ, ಬಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ದಂಡಿಗೆ ಇರಂಗಿಲ್ಲ. ನಾನು ಹೇಳ್ತೀನಿ ದ ಪೋಲ್ ಸ್ಟ್ರೆಂತ್ ಇಟ್ಸ್ ಸಿಚುವೇಟೆಡ್ ನಿಯರ್ ದ ಎಂಡ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟ್ ಬಟ್ ನಾಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅಟ್ ದ ಎಂಡ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟ್. ವಿ ಆರ್ ಕಾಲಿಂಗ್ ದಿಸ್ ನಥಿಂಗ್ ಬಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಎಂಡ್. This is exactly end. But where the pole strength is situated? Pole strength situated near the end of the magnet. And this pole strength having equal and opposite strengths. For south pole and north pole, they have equal strength, but they can separated by the opposite in direction. I mean, the pole strength has ability to attract the small pieces of iron, nickel, cobalt, or that what we are calling magnetic material. Those having equal strengths, but they are having opposite in direction. So that this pole strength has ability, and it is measured in terms of ampere meter. How it is measured? It is measured in terms of ampere meter. Simply, property of attraction mean what? Ability of the magnet to attract the small pieces of iron, nickel, cobalt, that we are calling property of attraction. Now, the second property is alignment property. Property of alignment. Property of alignment. Property of alignment. Simply, property of alignment means when a bar magnet or simply a magnet. Now let us take a bar magnet. When bar magnet freely suspend, it rests in a north-south direction. What I am calling? Let us take it is a bar magnet. When this bar magnet freely suspend, it stays in a north-south direction. How it is? Let us take a bar magnet. I am taking this is the bar magnet. This is the bar magnet. Right? When this bar magnet freely suspend, it aligns in north-south direction. Question arises, how to take north pole of the magnet and how to take south pole of the magnet. It is very important here. So here, when bar magnet freely suspend, it aligns in a north-south direction. The side which is aligning along the geographical north pole of the earth, that we are calling north pole of the magnet. Are you following? When bar magnet freely suspend, it aligns in north-south direction in such a way that the side which is aligning along geographical north pole, that we are calling north pole of the magnet, and the side which is aligning along geographical south pole, that we are calling south pole of the magnet. And the imaginary line joining from north pole to south pole, this we are calling magnetic length. This is the property of alignment. Property of alignment means when a bar magnet freely suspend, it aligns in north-south direction. Right. Now, third property is property of pairs. Property of pairs. Property of pairs. See here. The property of pairs mean we said that each magnet, either bar magnet, either U-shaped magnet, either magnetic needle, or you can take natural magnet also. Each magnet consists of a north pole and south pole. Right. When a bar magnet cut into so many pieces, either along horizontal direction or vertical direction, each pole or each pieces, they act as a north pole and south pole. How it is? Let us take. So I am taking a bar magnet. Simply I am taking a bar magnet. This is a bar magnet again call. Right. When this bar magnet cut into so many pieces, either you can take 2 pieces, 3 pieces, or you can take number of pieces. Either you can take vertically or you can take horizontally. Let us take it as a bar magnet. How to take it? So again let us take it cut along lengthwise. I mean along axis. Either bar magnet cut along vertically or along horizontally, each pieces they act as a magnet. How to confirm? If the pieces freely suspend, they align along north and south direction. So that always a magnet cut into number of pieces, so those each pieces again act as a magnet. I mean wherever a magnet exists, there must be one north pole and there must be a south pole. So that we can call the magnet always exists in pair. I mean wherever magnet is there must be a north pole and there must be a south pole. Simply you can call the monopole does not exist. I mean a single north pole not exist, a single south pole not exist. Wherever magnet there must be a north pole and a south pole. So that we are calling the property of pairs mean that the magnet is there. Wherever magnet, either you can cut along horizontally, you can cut along vertically. Each pieces again they act as a magnet. So that the property of pairs mean, property of pair indicates what? The property of pair indicates that always magnet is there. Either you can cut along horizontally, you can cut along vertically. Again they act as a north and south. So this is third property. The fourth property you can call. Fourth property you can call simply. The fourth property can be understood by taking 2 magnets. See here, how to take? Now I can take, simply I will take, this is nothing but bar magnet, right? So this we are calling north pole and this we are calling south pole, right? Again I will take one more magnet. Simply I will take one more magnet. See here, this we can taking, again now I am taking south pole and this one we are calling north pole, right? We found that when the south pole brings near to south pole, south pole brings near to south pole, they was repel each other. They was repel each other. Here south and south we are calling like pulses. Or you can take one more experimentally. Let us take it is nothing but north pole. Again I will take this nothing but one more magnet. Let us take it is south pole and this one we are calling north pole. It is found that when south pole and south pole brings together or north pole and north pole brings together, they was repel each other. They was repel each other. Here north and south and south, those we are calling like pulses. We found that the like pulses when they bring closer to each other, they was repel each other. They are repelling each other. That's what you can call the like pulses repel each other. Like pulses repel each other. Then let us take one more concept here. Now I can take again 2 magnets. See here, this is nothing but one magnet I can call. This we are calling north pole and this we are calling south pole. Right. One more magnet I will take. See here, this we are calling north pole and this we are calling south pole. Right. What we found? When north pole of the magnet brings near to south pole, they was attract each other. They was attract each other. I mean here north and south they are called unlike pulses. We found that unlike pulses attract each other and like pulses repel each other. Fourth property, what you can say? So here, simply I can call the fourth property, unlike forces attract each other, like forces repel each other. Look at me. See here, fourth property is unlike forces attract each other, and like forces repel each other, Simply, like unlike me, the south and north attract each other, south and south and north and night they were repel each other. So that I am calling unlike pulses attract each other and like pulses repel each other. But students, one point you can confirm that in electricity we are learning that repulsion is always a sure test for electrification. Maybe you have heard this term. Repulsion is always a surest test for electrification. In similar way, in magnetism we are calling repulsion is the surest test for magnetism. I mean, repulsion is the best method we can identify which is magnet and which is magnetic material. How to understand? Here one more property is there. Repulsion is the best method for magnetism. Look at me. See here. Here fifth property you can call. Fifth property, repulsion is the surest test for magnetism. Look at me. Fifth property you can call repulsion. Repulsion is the surest test for magnetism. I mean, repulsion method, it is the best method which is used to identify which is magnet and which is magnetic material. How it is? So in attraction there what happens? In attraction what is wrong? In the repulsion which is the best method? That we'll see. See here. Actually in the attraction what happens? That we'll see. Students, I will take two magnet and an iron piece. Simply see here. Now I can take a magnet. See here, this we are calling north pole, this we are calling south pole, right or wrong? Now I can take one more magnet. See here. Again this we are calling north pole, this we are calling south pole, right or wrong? I am taking two magnets. Already we know that unlike poles attract each other, because here what happens? North and south are attract each other, right or wrong? But here I can take one more object. Now just I will take a iron piece here. Simply I will take iron piece, right? See here, already we know that unlike pulses attract each other, but this magnetic material called iron, this iron also attract towards the magnet. Are you following? Because magnet has ability to attract the small pieces of iron. In this case attraction what happened? Unlike poles also attract each other and magnetic material called iron also attract each other. Here confusion may arises. Which is magnet and which is magnetic material? It is not easy to identify. I don't know. So this is the north pole. Right or wrong? So let us take it is nothing but south pole. If it is north pole, this also attract, this also attract. Here confusion may arises. Confusion may arises which is magnet and which is magnetic material. Right or wrong? But in repulsion what happens? In the repulsion, let us take it is nothing but south pole, and what about this? This is nothing but the north pole. Right or wrong? Here what happens? South and south are repel each other. Repulsion takes place, and the iron material which attract towards the magnet. During repulsion you can identify this is south and south, then I can call both are the magnets. If iron pieces attract, then what you can confirm? From this you can confirm that which material is attract, that we are calling magnetic material, and which material is repelled, that is nothing but magnet. So that In repulsion, what happened? We can identify which is magnet and which is magnetic material. Here iron we are calling magnetic material. In this case, what can confirm? Repulsion is the surest test for magnetism, because only the one reason during repulsion and during attraction, during repulsion and during attraction, we can identify which is magnet and which is magnetic material, that you can easily identify. So that repulsion is the best method for magnetism. Let us students, already we know that the bar magnet, it is a rectangular cross section magnet which has the ability to attract the small pieces of iron, nickel, cobalt, and when it is freely suspended, it aligns in north-south direction, right? Then in moving charges and magnetism, we are learning that wherever current is passing in the conductor, around it magnetic field is produced, right or wrong? Just we have learnt about the magnetic field. How to define their magnetic field? The region or space around current carrying conductor within which another magnet experiences magnetic force. This concept we have learnt already, right or wrong? Then actually, how the picture of magnetic field is there? The picture of the magnetic field simply you can by taking a bar magnet and by taking the iron pieces. Very small iron pieces you can take, and you can take a bar magnet. By taking that, we can understand the concept of magnetic field and concept of magnetic field lines. So let us take now the concept of magnetic field lines. See here. Now let us learn the concept of magnetic field lines. See here. Magnetic field lines. Right. Students, what we found in the last class? When a current is passing in the conductor, around it a field is modified. That field we are calling magnetic field. Right. Now, pictorially we will see how the magnetic field lines are there. We can understand simply the magnetic field lines property can be understood by taking a bar magnet. Simply I will take a bar magnet. Look at me. Now I will take a bar magnet. Consider it is a bar magnet. So each bar magnet that consists of a north pole, right? So consists of a south pole. The imaginary line joining from north pole to south pole, this we are calling magnetic length, right? The concept of magnetic field lines can taking the small iron pieces. When small iron pieces are spreading around this magnet, small iron pieces are spreading around this magnet, they will arrange around this magnet in a definite pattern. If the case, the small pieces of iron, if they spread out on the magnet, those iron pieces they will arrange like this. Shall I take how they will arrange? They will arrange like this. Look at me. Like this they will arrange. They will arrange like this. In this pattern they will arrange like this. In this pattern they will arrange. I mean, if you take very small pieces of iron, the small pieces of iron, it is spread out on the given bar magnet, they will arrange in a different pattern. If we join all these imaginary lines, these imaginary lines indicate the pictorial representation of magnetic field around a given bar magnet. How? Let us join. So shall I join all these lines? If I join these lines, these represent magnetic field lines. Are you following me? This one represents magnetic field lines. So this one also represents magnetic field lines. Right? This one also represents magnetic field lines. Let us join all the imaginary lines. Right. This also I will join imaginary lines. Right. Let us take all the imaginary lines. Simply I will join in. I am joining all the imaginary lines. Right. These are the imaginary lines around a given bar magnet. How to understand this? When small iron pieces spread out around the given magnet, so they will arrange in a different pattern. Right or wrong? Right or wrong? How they will move? The magnetic field lines, they can move like this. Like this they can move from North Pole to South Pole. North Pole to South Pole. See here. They move from North Pole to South Pole. See here. Like this. Like this they will arrange. Right. They will arrange like this. Like this. So outside the bar magnet, magnetic field lines can travel from North Pole to South Pole, and inside the magnet they move from South Pole to North Pole. Like this, simply. How they are? Around a given magnet, if you spread out the small pieces of iron, they will arrange in definite pattern. So shall I draw in one more figure here? Let us take a bar magnet, or once again shall I draw how the magnetic field lines can exist around a given magnet? Look at me. So if small piece of iron are spread out, they will arrange like this around a given magnet. These are represents the magnetic field lines of the given magnet. Similarly, you can take current also. When a current carrying wire passing through cord sheet, around it iron pieces spread out, they will arrange around current carrying conductor in a different pattern. Those represent magnetic field lines. Similarly, around a given magnet, if you spread out the small piece of iron, they will arrange in a different pattern. Like this they will arrange. So in separate diagram I will draw how the magnetic field lines can exist. Look at me. In detail we will see. See here. So I can take it is a magnet. So each magnet consists of a North Pole and South Pole. This we are calling North Pole, right? This one I can call South Pole. The magnetic field lines, how they will go? North Pole to South Pole outside the magnet, and South Pole to North Pole inside the magnet. Similarly like this. Like this I will go. North Pole to South Pole outside the magnet, and South Pole to North Pole inside the magnet. Like this. So like this they will arrange. Like this they will arrange. See here. How they will go? If it is nothing but North Pole, this is South Pole. How they will go? They will go from South Pole, North Pole to South Pole outside the magnet, and South Pole to North Pole inside the magnet. Again like this. North Pole to South Pole outside the magnet. Outside the magnet. Shall I take it? See here how to take. South Pole to North Pole. North Pole to South Pole outside the magnet, like this. Like this way. And inside from South Pole to North Pole. Like this. Like this I will go. How they will go? Like this. Like this. Like this. See here. Now let us see what is magnetic field lines and what are the property of magnetic field lines. See here. Magnetic field lines are nothing but imaginary curved lines. The imaginary curved lines which represent magnetic field of a magnet. What is magnetic field lines? The imaginary curved lines. The imaginary curved lines which represent magnetic field of a magnet. Those we are calling magnetic field lines. These magnetic field lines have a definite property. Right. Then let us see in detail what are the properties of the magnetic field lines. In detail we will see. Simply you can call magnetic field lines are nothing but a pictorial representation of magnetic field. How the magnetic field can exist around current carrying wire, or how the magnetic field lines can be exist around a given magnet. That pictorial representation nothing but nothing magnetic field lines. Now let us see in detail what are the properties of magnetic field lines. In detail we will see. See here. Concept is properties of magnetic field lines. Properties of magnetic field lines. Magnetic field lines. See here. Let us take first property of magnetic field lines. First property of magnetic field lines. First property is magnetic field lines are imaginary curved lines or the imaginary lines which travels from north pole to south pole outside the magnet and south pole to north pole inside the magnet. What these are? The imaginary lines or imaginary curved lines which moves from north pole to south pole outside the magnet and south pole to north pole inside the magnet. How to take? First property, the imaginary lines, the imaginary curved lines, which moves north pole to south pole outside the magnet and moves south pole to north pole inside the magnet. This is first property. Then let us see second property. See here. Second property you can see. Already we know that magnetic field lines are nothing but imaginary curved lines. Question is how to take the direction of magnetic field lines. See here. Second property indicates that the tangent drawn at any point to the magnetic field lines or the tangent drawn at any point to the magnetic field lines represent direction of a strength of magnetic field lines. What is second property? The tangent drawn at any point to the magnetic field lines indicate the strength of direction of magnetic field. See here. How to second property? The tangent drawn at any point. Tangent drawn at any point to the magnetic field lines. Magnetic field lines indicates direction of strength of magnetic field. Direction of magnetic field, simply. Direction of magnetic field. Tangent drawn. The tangent drawn at any point. To the magnetic field lines indicate direction of magnetic field lines. The second property indicates that the magnetic field lines having unit direction. Magnetic field lines only having single direction. Right. Magnetic field lines not having double direction. Then third property indicates that two magnetic field lines never intersect each other. Third property indicates two magnetic field lines never intersect each other. See here. Two magnetic field lines never intersect each other. Never intersect each other. I mean, if this is one magnetic field lines, this is second magnetic field lines. These two magnetic field lines never intersect each other, because if the magnetic field lines are intersect each other, at the point of intersection, two directions are possible. Are you following me? What I am saying? If two magnetic field lines are intersect each other, what happens? At the point of intersection, two directions are possible. This is one direction and this is second direction. But what second property says? Tangent drawn at any point to the magnetic field lines indicate direction of magnetic field. This direction only having one direction, I mean only single direction. If the magnetic field lines are intersect each other, at the point of intersection, two directions are possible, which is not possible from this figure, because the second property indicates only magnetic field lines only having single direction. Look at this. This only having single direction. If they intersect each other, at the point of intersection, two directions are possible. This is third property. And fourth property indicates that magnetic field lines form continuous closed loops. Magnetic field lines forms continuous closed loops. Closed loops mean, look at me. Magnetic field lines travels from north pole to south pole outside the magnet and south pole to north pole inside the magnet. This is continuous closed loop. This is continuous closed loops. But electric field lines never form continuous closed loops. But magnetic field lines form continuous closed loops. What it is? Magnetic field lines form continuous closed loop. Look at this, or look at this. Magnetic field lines travels from north pole to south pole outside the magnet and south pole to north pole inside the magnet. It is a continuous closed loops. So that what you can call fourth property? Fourth property you can say that magnetic field lines form closed loops. Forms closed loops, or they form continuous closed loops. Continuous closed loops. See here. Look at me now. These magnetic field lines simply they can travel from north pole to south pole. How they can? Look at me. I can take it as simply magnet. I can take it as a magnet. This is north pole, I can call, or I can call this is the north pole, this is nothing but south pole. How they will travel? Magnetic field lines travels from north pole to south pole outside the magnet and south pole to north pole inside the magnet. Look at this. Look at this one. This is nothing but closed loop. From what point they starts, again they end at the same point. So this means it is a closed loop. So that magnetic field lines form continuous closed loops. And next property we are going. See here, fifth property you can go. Fifth property is nothing but the more number of magnetic field lines passing per unit area represents stronger magnetic field lines, and less number of magnetic field lines passing per unit area represent weaker magnetic field. Simply I can take a material. Look at me. This is nothing but one material. Are you following this? If the magnetic field lines are more passing here, magnetic field lines are more passing, this represents stronger magnetic field. This represents stronger magnetic field. Now I can take one more. Look at me here. I can take it as a material, but in this material if less number of magnetic field lines are there, this represents weaker magnetic field. I mean, fifth property indicates more number of magnetic field lines passing per unit area represent stronger magnetic field. Less number of magnetic field lines passing per unit represent weaker magnetic field. I can take simply, if more lines are passing, these are nothing but more lines in a given surface, this is stronger magnetic field. This is a stronger magnetic field. And if the case magnetic field lines are widely spaced out, like this, widely spaced out mean like this is nothing but weaker magnetic field. Simply I can call fifth property, more number of magnetic field lines passing, more number of magnetic field line passing, magnetic field lines passing, magnetic field line passes, indicates stronger magnetic field, indicates stronger magnetic field, stronger magnetic field lines, and less number of magnetic field lines passing per unit represent weaker magnetic field. So these are few important property of magnetic field lines. What are those? Magnetic field lines are imaginary lines which moves from north pole to south pole outside the magnet and south pole to north pole inside the magnet. Tangent are drawn at any point to the magnetic field lines indicate direction of magnetic field. Two magnetic field lines never intersect each other. Magnetic field lines form continuous closed loops. And fifth one is the more number of magnetic field lines passing per unit area represent stronger magnetic field. On the other hand, less number of magnetic field lines passing per unit area represent weaker magnetic field. So these are few concepts concerned to magnetic field lines. The remaining concept we will see in the next class. Thank you, students.